Hi, my name is Sarah, and my project is on something called thaxtomins. And so you can see what a thaxtomin molecule looks like in figure 2 on my poster. That's just one example. They're cyclic diketopiperazines, and we're interested in them because of their role in as a virulence factor in streptomyces, and they can inhibit cellulose synthesis, and so they can be used as an herbicide. And herbicide is a really economically valuable field right now because the existing herbicides that we have are becoming less and less effective. We're also interested in this from a medical standpoint because early research has shown that these types of molecules can potentially be used for antifungal, antiviral, and antibiotic applications when they're used as medicines. So in order to do this, their natural synthesis is pretty low in their native producer, streptomyces, so we wanted to do an in vitro approach, so outside of their natural producer and without cells at all. So what we were able to do was directly produce thaxtomin enzymes from different amino acid analogs, and combine those enzymes to then create the analogs that we were looking for. So what we found were that some in particularly important thaxtomin enzymes were TXTA and TXTB. They possessed unique substrate binding affinity, which allowed them to create several different analogs. In particular, L-phenylalanine and L-tryptophan analogs were the most effective amino acids in creating different types of thaxtomin analogs that we were looking for. And then also one of the thaxtomin enzymes, in particular TXTC, demonstrated that it was able to hydroxylate the compound both aliphatically and aromatically, which is just a really interesting finding for this research, and also just different organic synthesis research, and that can be used for a wide variety of applications. We also then used our findings of these different analogs to measure the herbicidal activity and see how effective they were at herbicides, and we found several different analogs had really high herbicidal activity. So in conclusion, we were able to synthesize 124 unique thaxtomin analogs directly just from amino acid components, and we were able to characterize what different different thaxtomin enzymes do by combining them and figuring out which analogs they created. And then we also discovered that very unique quality of TXTC. It's able to hydroxylize different positions, and then we're also able to find several analogs that had potent herbicidal activity.